Sup guys, today today I'm going to show you how to make a Collatz conjecture calculator or a 3x plus 1 calculator because that's its other name. Sorry, let me get rid of this ad. Okay, never mind, whatever. Basically, if you don't know what Collatz conjecture is, it's basically a simple but really hard math problem. So basically, the premise is simple. If it's even, half it. If it's odd, times it by 3 and add 1. But the thing is, take any number and use those rules repeated. What? Okay, number. Repeat it and over and over and over and over again, and eventually it will always end up in an endless loop of 4 divided by 2 to 2 divided by 2 to 1. 1 is odd, right? So times it by 3 and add 1 equals to 4. So any number, it will always end up in that endless loop, or any positive discovered number. So multiple mathematicians have been trying to see if there's any number that doesn't follow that rule. There has been a bunch of numbers, or there's been a bunch of numbers that mathematicians have tried, and they all follow this rule. I'm not sure how many it is, I think it's like 2 raised to a tetration something, I don't know. Oh yeah, I'm gonna make a tetration calculator soon. Anyways, let us start. So now, make a forever loop, make a while true. It's cooler to say forever loop, okay? So basically, this will repeat whatever we put in the tab, in its tab or whatever, will be repeated forever, or while we run this code. So now, make a variable. It's going to be called num or whatever you want it. Make it to an integer input. Remember the integer input? Or remember the integer part? Because if you don't add integer and just have input, then that means whatever you write in, even if you write some numbers, that means it will be stored as a string value or a text value in short. So right here, enter a number, enter a number. Okay, now make another variable, TST. It stands for total stopping time. I'll explain it more later. But for now, just set it to 0. And then while num does not equal to 1, it will repeat this code. So now this is when the Collatz conjecture part starts. So basically, to check if it's even, you have to do if num modular or percentage sign 2 equals to 0, then that means it is even. So now we want it to half. How do you do that? Do this. Num equals num divided by 2. And then to check if it's odd, just do an else. Alright? Num equals num times 3 plus 1. Right now, backspace. Write a print. No, actually, no. There you go. You have to print the variable num. Shoot, I messed up. Shoot, I keep on messing up. I'm supposed to click enter. Print the variable num, and then change TST, or total stopping time, by 1. So basically, because total stopping time is basically the amount of times it will we have to repeat this code until the number is 1. Okay, after that we will print an F string, which is which is total stopping time. Then put in the variable total stopping time. Finish up that. Shoot. There. So now we are practically done. Put in any number, let's do 27. Then boom. They got all of that. So it goes really high for sometimes one, then it goes all the way down to 4, 2, 1. And then the total stopping time is 111 because that's how many times you have to repeat this code. So you may be wondering, why did I import time? Well, it is because if you wanted to have like a cool, maybe like load effect, do a time.sleep. This is not needed. If you're okay with how it is right now, then that's good. Time.sleep 0.25. Let's try doing that. Now look, let's do 27 again. Now look at that effect. That's nice, ain't it? So it will take way longer, but if you want to, you can use that. So let's wait for this to clear out. It's actually gonna take a while. Because remember, 27 is like 111 total stopping time. It's getting lower though. There you go. Total stopping time 111. So you can choose if you want to add that. I don't really like it. So if you want, you can experiment with a bunch of numbers here. Maybe you can do some random numbers. Like let's try whatever this is. Let's do that. But look at that. Total stopping time has the answer to it. It finishes it completely. It has a higher than 27, obviously. Actually, remember 27 was a 111? Now let's try doing 26. Look at that absolute difference between just one letter. I mean, just one, number. Even 28, it's so different from 27, which it's 111. So you can experiment with this. Maybe you can find the number. You never know. Like maybe you could find the number, which is the infinite loop, and it will never reach. Like let's try this. Honestly, I doubt because look at this massive number. It still goes all the way down to 0. I mean 1, sorry. So yeah, you can experiment with this code, do whatever you want with it, or maybe you can just flex it to your friends. So thank you guys for watching, and please subscribe. Bye.